So to further explore data frames, we'll want to look at a larger data set. So for example, we'll use the Galton data set from the Mosaic data package. I'll quickly store that in my global environment, and we will attempt to print that to the console, and we see that it's sort of immediately overwhelmed. RStudio actually restricts how much of it it'll show to us. So to get a look at the data, we'll use the view function with a capital V. This is actually an RStudio specific function because when I run it, it opens up a data viewer in RStudio. We could also open this by clicking the data set name or data frame name that is in the environment tab. And this just gives us a quick overview of the data. We have the ability to scroll and we're not restricted by the console here. We see that all the data is here actually. We can do some quick filtering. Say we could sort height lowest to highest, highest to lowest. We could filter to a particular gender. If we click filter here, maybe we find really tall boys in this data set. It's just a really quick way to get a broad overview of your data. If you wanted to do that without having to open up the viewer, if you wanted to maybe just get an idea of what variables are in the data set, you could use the head function and you can tell it how many observations you would like to see. So here we see first 10 observations, so we get an idea of what variables we're dealing with and sort of what are some typical observations here. Again, we can use the structure function to get the structure of the data frame, which can also be seen by expanding the data frame in the environment window. And again, we see these factor variables. So for now, you should just know that a factor variable is essentially how R is dealing with a categorical variable. So in this case, the sex variable takes two possible values, M and F, male and female in this case, and R says that there are levels M and F. So we could extract those directly. And that's essentially saying this variable can only take those two values. If we try to change one, if we try to add a third or fourth possible category here, R would not let us do that. The thing to realize right now is that data frames will automatically make character values into factors. That's what we saw happen back with our example data here. So this vector, as a vector, it's character, but when we introduce it into a data frame, it becomes a factor variable. Much like every other data structure we've seen before, we would like to potentially subset our data. So to extract a particular row and column, or that is a particular observation from a certain variable, we could subset this sort of like a matrix. We could leave the row blank and extract a certain column. Maybe we forget what variable this column is, so the names function will help us out here. That is, we took the second column, which is the father variable, so the height of the fathers in this data set. And we could also leave the column information blank and get rows of the data set. So here's the first observation of the data set. So this is sort of subsetting a data frame as if it were a matrix. We could also subset a data frame as if it were a list. So I could say, give me the fifth element of the list, which should be 1, 2, 3, 4, 5, the height of the children. So notice that this gives me back a data frame. That might be difficult to see here, but this is a data frame. We can tell it's not a vector because these aren't in brackets. Whereas back here, say, for example, if I took the second column this way, this was a vector. So keep that in mind. So I could also say, get the first two elements of the list, which in this case are the first two columns. And again, this is a data frame that's being returned here. We already saw that we can use a $ operator to extract named elements from lists, and those are the columns of a data frame. So here we're extracting the heights of the fathers. Again, this is returning a vector. This is the same thing, but again, so this, using the $ operator gave us a vector, but using the 2 for giving me the second element of the list, that returns a data frame. So similarly here, instead of using 2, using the name and the sort of list subsetting syntax, this would also give me a data frame back. But if I want the element of the list, the vector itself, I would use the double bracket syntax. We can sort of do some more complex subsetting. So for example, here what I'm doing is first I'm creating a logical vector of finding where the gender variable is female, and then subsetting to those rows, and then finally selecting the heights. So these are the heights of the female individuals in the data set. Similarly, I could use the subset function. So this says subset the Galton data set, and the subset I want is where heights are greater than 70. So it's automatically, because this is all inside the function call, it knows I want to deal with the Galton data set, and I wrap that with the head function, so I see the first 10 rows. So these are the first 10 rows where the height is greater than 70. So far we've been using a data frame. Recently in R, there's a new package called Tibble. A Tibble is essentially a data frame with two differences. We would say it prints in a sane manner and it subsets slightly differently. So first I'll coerce the Galton dataset, which is currently a data frame, to be a Tibble. And then I will print it to the console, and we see this is vastly different from what happened when I just print a data frame. It automatically only prints some of the observations, and it gives me some additional information here. So it essentially prints only the first few observations, and it also gives me the structure information. So I see the number of observations and the number of variables. I see the variable names, and in addition I see the types of the vectors for these variables. So I see that family is a factor vector. I see that mother and father are both doubles. I see the sex is factor, height is double, and so on. That's the first difference between a Tibble and a data frame, is that it prints in a more sane fashion, but it also subsets slightly differently, and you just need to be aware of this. So remember that right now Galton is a Tibble, not a data frame. So when I try to subset using, for this example, the sort of list syntax, this gives me back another Tibble. If I use the $sign operator, that means give me the element of the list. This will return a vector. Now, before we saw that these with a data frame, when I sort of did things more like a matrix, it reduced down to a vector. But here we will see that the result remains as a Tibble in both cases. So you can sort of think of this as this is always sort of operating like a list. So the only way to get the element is to specifically request the element. Otherwise, it's going to give us back a list, or in this case, a Tibble. If we switch back to data frame real fast, so we see that if I use the list syntax here, this will give me back a data frame, which prints rather poorly again. If I use the list syntax and say give me the named element, it'll give me a vector. But now, because we're back to a data frame, when I subset sort of like a matrix, these will reduce to a vector and again a vector. One minor note here is in some older R references, you'll see this attach function used for data. Sometimes you would be told to attach a data frame. And that would essentially allow you to directly access the variables without needing to use the $sign syntax. You might think that this makes things easier and code look nicer, but you should never do this. For example, I'm going to, for no particular reason, create a height variable here, and then I'm going to attach the Galton dataset. And I get a little warning here, but let's see what happens. So if I look at the father variable, I can now access it directly. I don't need to use the Galton data sign father. While it's not directly in my global environment here, we see that Galton is now loaded, so I can directly access the variables here. Now, there's a slight problem though, because height is in my global environment. So when I make this comparison, it works with no complaint, because this happens to be of the correct length that when I repeat it, it's the same as father, but I'm not comparing father from the Galton dataset to height from the Galton dataset. I'm comparing father from the Galton dataset to height, which is right here. What I'm actually trying to do is this, but I'm not getting it because my workspace is not what I expect it to be because I've attached Galton. So bottom line, never use the attach function.